For the continuation of the topics under the applications of spherical trigonometry, we have the terrestrial triangle. It is a spherical triangle which has the north or south pole as one of its vertices. In the illustration on the right, so we can see here the shaded portion. It is an example of a terrestrial triangle. And as what you can see, so we do have here the point A, the point B, and then another point is actually one of the poles. So in this example, or in this illustration, so we do have the third vertex at the North Pole. So this terrestrial triangle, this is actually used if we would like to solve, or we would like to determine the distance between 2 points on the sphere. So in well, when it comes to the Earth, so we can make use of this concept on terrestrial triangle if we do have two places or two cities that we would like to know the distance that is between the said two places. And then considering that there is one pole. So either the north or the south. So depending which one is what, which one is being considered. So in this lesson, so we're gonna have three examples that we're gonna discuss. For the first example, find the distance between San Francisco with the coordinates 37 degrees, 48 minutes north, and 122 degrees, 26 minutes west, and Honolulu with the coordinates 21 degrees, 18 minutes north, and 157 degrees, 52 minutes west. So how are we going to solve this? So the first thing that you need to do is you try to draw it. Okay, you need to illustrate so that you can better understand, or you would know what are you going to do when it comes to solving the said problem. So first, let us have the sphere. Okay, so when you draw the sphere, so we do have here the north, we have here the south, the west, and then the east. Okay, and then since as what you can notice that the two longitudes are on the west, so we're gonna have the primary region, okay, in this portion. Next, then we're gonna have the equator. Okay, so this is the equator. This one is the primary region. Okay, and then the next thing that we need to do, we need to well, we need to locate. Okay, where is San Francisco? So the first place is 37 degrees 48 minutes north. So it is above the equator. Okay, so that you're gonna measure 37 degrees. So say that the 37 degrees is here. Okay, so this is the 37 degrees, 48 minutes. Then north. So you're gonna draw, okay, circle here. So of course you also have at the back, okay, continuation of the circle. And then the next, we do have a longitude of 122 degrees, 26 minutes west. So for the longitude, we're gonna measure that is from the primary region, okay, towards the west. So we're gonna measure 122 degrees. So for example, if this is the 122 degrees and 26 minutes west, so from the north, so you're gonna draw the meridian here, okay, up to the south. okay, from north to south. And then the point of intersection, this is actually the San Francisco, okay? Or if you want, you can just label it as S, okay, the S here. So let us just make it S. Although we do have an S for the south, but then it is color blue, so it's okay. And then the next thing that we need to do is for the Honolulu. Okay, so the latitude is 21 degrees, 18 minutes north. So it is again above the equator. So you're just gonna measure 21. So for example, the 21 is here. So 21 degrees, 18 minutes north. Then again, you draw a circle. Okay. Then at the back, you just try to imagine. And then with a longitude of 157 degrees, 52 minutes west. So again, from the primary region towards the west, we're going to measure 157 degrees, 52 minutes. And then draw the meridian from the north, okay, passing through the 57 degrees, 157 degrees, 52 minutes. Okay, then up to the south. There. Then we do have here the point of intersection. So we're going to label this point as H. Okay. So I'm just putting a big dot for the point so that you can easily see. So when it comes to the drawing, possible you can just have the intersection and then you just name the said intersection. Okay, but then just to make it clearer or to easily see the points of intersection, so I made use of big dot. Okay, next. So what is the question here? The question here is we're gonna find the distance. Okay, so it is said in the problem we're gonna find the distance between the two said places. So the distance between San Francisco and Honolulu. So this is what we need to know. Okay. Just to clarify, so since this is a spear, so it should be what? It should be somehow well in the form of arc. Okay. So as what you can see, so we already have here a terrestrial triangle. This is a terrestrial triangle. So if you want, you can shade it so that you can easily see. Okay, there. So this is that terrestrial triangle. And if we are going to draw it, okay, with well, having just the triangle alone, the terrestrial triangle alone, so you can draw it this way. So we have an arc, okay. So that is a portion of the meridian, and then also another arc here. So you can notice that the S is, well, it is above the H. Then we do have the distance between the said 2 points. So again, we have here Honolulu, we have the San Francisco, and then we have here the North Pole. Okay, so this is how the terrestrial triangle will look like. Next, so how are we going to solve for the distance? So as what you can see, this is actually an oblique spherical triangle. And what we can do with this is we can solve it using the law of cosines. Okay, but then before we solve for this, if you can remember for the law of cosine, so what we use are the letters A, B, and C. So to make it easier for you, so you just assign letters first. So for example, if you would like your H, okay, for example, your H, this will be your A, okay? And then San Francisco, which is the S, so it will be B. And then the north, so we can assign this, okay? Assign on here letter C, the big C. So this means that the sides opposite the big A, big B, and big C. So we can already assign letters already. Okay, the small a. So opposite the big A, so we have here the small a. Okay. And then if we have here the big B, so we have here the small b. And then if we have here the big C, so we have here the small c. By the way, in terms of the original letters, so we can just put it. So if we have here H, so this means this is H. Okay. Then this is the S. And then this is N. Okay. Next. So how are we going to solve this? So the first thing that you need to consider are the given. Okay, are the given. So possible, since the coordinates are given, so let us try to identify what can be the value of H here, which is our small a. So from the north, okay, so from the north, then we do have here San Francisco. So it is said that the latitude of San Francisco is 37 degrees 48 minutes north. So this is 37 degrees 48 minutes north. This is the latitude. So if we would like to know the measure of small a here, which is our small h, if you can still remember our lecture about the colatitude, so it means we can subtract the latitude of S from 90 degrees. Okay? So it means that H is 90 degrees minus the latitude 37 degrees 48 minutes. And therefore, what would be the value of H here? So it would be 52 degrees and then 12 minutes. Okay, so that is the measure of side H. Next, for S, we're gonna do the same. So since Honolulu has a latitude of 21 degrees and 18 minutes north, so we can make use of the concept about what? The colatitude. So we can subtract the given latitude from 90 degrees, and it will give us what? A measure of 68 degrees 42 minutes. Okay, so you can just use your calcu. So that is so the first one we do have 90 minus 37 degrees and 48 minutes. So the DMS format is 52 degrees and 12 minutes. The other one, so 90 minus 21 degrees and 18 minutes. So in DMS, the difference is 68 degrees and 42 minutes. So in this case, we already have the measures for A. So let us make use of the ABC. So we have a measure for A. So it is 52 degrees, 12 minutes. We already have a measure for B. So that is 68 degrees and 42 minutes. So with these two given, we cannot solve yet Because remember, we should have three givens. The small c here is actually the unknown because the small c, which is the small n, is the distance between San Francisco and Honolulu. And it is what being asked in the problem. Okay, so if we try to look, what we can use is what? What we can use for the other given is the longitude. So the longitude of San Francisco and then the longitude of Honolulu. So if we're going to make use of the two longitudes here, what we can solve is actually the angle, okay, on n, which is our what? Which is considered to be the difference in longitude, if you can remember. So if we're going to solve for the difference in longitude, so the difference in longitude, so remember, since the two longitudes are on, both are actually both on west. So we're just gonna subtract the smaller from the bigger. So we have 157 degrees, 52 minutes minus 122 degrees, 26 minutes. So we have the difference in longitude. So you just use your calculator. Then your answer should be in DMS2. So the difference in longitude is 35 degrees and 26 minutes. And then remember, this difference in longitude is actually our what? It is actually the big C. So big C equals to 35 degrees and 26 minutes. Okay, and then what do we need again? So we need the small c. So if you try to look at the measurements that we do have here, so we have A, B, and then big C. So the A, B, and C are complete. So what we can use here is the law of cosines. Okay, the law of cosines. So the law of cosines for what? So since we do have more sides than angle, because we do have here three sides. So the side A, the side B, and then the unknown. So what we're gonna use is the law of cosines for sides. That's it. So we're gonna switch to the black screen. So I'll just write again the given. So we have small a that measures 52 degrees and 12 minutes. We do have the small b. It measures 68 degrees and 42 minutes. We do have a big C. It measures 35 degrees and 26 minutes. And then what we need is the small c. Okay, so in the law of cosines, for sides, so we know that, well, one of the formulas that we can actually use is the third one, because we do have here a small c, a big C. So the third formula is what? So that is the cosine of the small c equals. So remember that on the right side, we do have cos, cos, sine, sine, cos. So we have cosine of the other two sides. So cos A times cos B. Then the operation is addition. sine A, sine B, cosine of the angle C. That's it. And then since what we need is the small c, okay, so we have small c equals, so the cosine, we can move it to the right side. So it will become r cosine of the cosine of A, cosine of B, plus sine A, sine B, cosine of the big C. Okay, now, what we can do is we can already substitute. So we do have, so substituting, so we have C equals R cosine. So the cosine of small a is 52 degrees and then 12 minutes times cosine of B, that is 68 degrees and then 42 minutes. Then we're gonna add it with sine of small a, 52 degrees and then 12 minutes, times sine of small b, 68 degrees, 42 minutes, times the cosine of the big C that measures 35 degrees and then 26 minutes. And then you just use your calculator. So you input it. So you should have your answer in DMS. So in DMS, the answer is 34. That is 34 degrees, 40 minutes, and then 1.04 seconds. So that is 1 second. So this is actually the measure of big C. Okay, so this is measure of, this is actually small c. Okay, the measure of small c or measure of side C. Because our big C is 35 degrees and 26 minutes. Next, since what we need is the distance, so if you can remember in our drawing, so in our drawing, so if you have your A, B, and then this is the big C, so this is the small c, this is a small a, this is the small b. Okay, so if you can remember the drawing, well, has the small c, which is actually the distance between the big A and big B, or the Honolulu and San Francisco. So what we're going to do with this, so we need to convert, okay? We need to convert to distance. So we need to convert the angular, okay, the angular measure to distance. And how are we going to do this? So the first thing that you need to do, so you need to have this in degree, okay? And then after having this in degree, so you convert this to minutes. Then after converting to minutes, you convert this to nautical mile. Remember, 1 minute is 1 nautical mile. Okay. So after you did this, so you already have the distance in nautical miles. So let us convert. So we have 34 So 34 degrees and then 40 minutes, 1 second. So this is actually what? Equivalent to, so I'll just write it in this portion. So C equals 34 degrees, 40 minutes, 1 second. This is also equivalent in decimal. That is 34.666. Please use 5 decimal places because this is not yet the final answer. But then no need to round off. So 34.66695 in the calculator. So the unit of this is degree. Okay, then the next thing that we need to do, we need to convert this to minutes. So in converting this to minutes, so we know that what? In 1 degree, okay, in 1 degree, there are 60 minutes. Okay. So you need to put the 1 degree on the denominator because what you need to do is you need to cancel the degree. So we have, so in your calculator, you just multiply it by 60. So the answer is 2080.02. Okay, because that is 017. But then since this is not yet the answer, so let us just have the three decimal, the 51737. Okay, then the unit is minute. Okay, then since 1 minute is equal to 1 nautical mile, okay, so it means that we have 2080.02 nautical miles. So this is the distance. Okay. So if we would like to answer the question, so we can say that the distance between San Francisco and Honolulu is 2080 2080 nautical miles. So based on our answer, so this means that the small c is so 2080 nautical miles. So in answering the question, so that is actually the distance. Okay, next. So what if, for example, you will be asked of what is the bearing? What is the bearing of San Francisco from Honolulu? So if you will be asked of the bearing of San Francisco from Honolulu, so bearing, what is the bearing of San Francisco from Honolulu? So the from is on H. So it means that we're going to have the bearing on H. So the bearing is actually here. Okay, so this is the bearing. So if you would like to answer this additional question, so we can use again the law of cosines. So let us have the black screen. So I'll just rewrite the given. So A is 52 degrees and then 12 minutes. B is 68 degrees, 42 minutes. And then the big C measures 35 degrees, 26 minutes. And then based on our illustration a while ago, So if this is Honolulu, so it is on A, this is B, and then big C. So this is what we need, okay, the theta here. So again, A is again Honolulu. So based on our computation a while ago, we were able to get the measure of small c. The measure of small c in angular measurement, it is 34 degrees 40 minutes. So let us just have the dm, the degree and minute. Okay. So with this, as what you can notice, what we need here is the big A. Okay, the big A, because it is the theta that is being asked here. It is actually the bearing. Remember, the bearing is from the north, okay, from the north, and then it should be clockwise towards the arc AB, or arc of Honolulu and San Francisco. Okay, so if you can remember our discussion about bearing. Okay. So with this, we're gonna stick with the law of cosines. So law of cosines, is it for angles or for sides? So it would be what? For sides. Why? Because we have the measure of the small a, the measure of the small b, and then the measure of the small c. And then what we need is the big A. So in this case, we're going to make use of the first formula. So that is the cos of small a equals to cos of b cos c plus sine b sine c cos of the big A. So remember, what we need here is the big A. Okay, so let us derive. So we have cos A. This one, okay, so remember, this is considered to be what? A whole. So we can move it to the other side. So it will become negative cosine B cosine C. That's it. Then on the right side, the remaining sine B sine C cosine of big A. Again, what we need is the big A. So in this case, we need to get rid of the sine B sine C on the right side. So in order for us to do that, so we're gonna divide it by sine B sine C. Same with the left side. Sine B sine C. Okay, then we can already cancel this. So we do have cosine of big A. On the left side, we have cosine A minus cosine B times cosine C over sine B sine C. Okay? And again, remember, what we need is the big A only. So we do have big A equals. So the cosine here, we can move it to the other side. So it will become our cosine of the cosine of small a minus the cosine of small b cosine of small c over sine b sine c. Okay, so this is already the derived formula. So after this, we can already substitute. So we do have big A equals our cosine. The cosine of A, so cosine 52 degrees 12 minutes minus so minus cosine 68 degrees 42 minutes cosine 34 degrees 40 minutes then divided by, so we're going to divide it by sine of 68 degrees, 42 minutes times sine of 34 degrees, 40 minutes. So just use your calculator. So you input it in your calcu. So the answer should be in DMS. So it is 53 degrees, 38 minutes, 43.69 seconds. So you just round it off. Okay, round off the last portion. So we have A equals 53 degrees, 38 minutes, and then 44 seconds. So that is the measure of angle A. Okay. So in order for us to answer the question, so I will remove this portion. So since we are asked about the bearing, so what is the bearing of San Francisco from Honolulu? Okay. So in our illustration, remember that A is the Honolulu. Okay, this is the H. B is the San Francisco. Okay, then C is the North Pole. Okay, to answer the problem, so we need the bearing. So from the north, so it means that if we're going to have, so north, south, west, and then east, and then we do have here, we have here the H. So from north, so this angle here, okay, so from north, it measures what? So it measures 53 degrees, 38 minutes, and then 44 seconds. So to answer the problem, so we can just have the answer. So just consider the degree and minute. So we do have 53 degrees, 38 minutes. And then based on our illustration here, okay, with the directions, the north, south, west, and east. So with the bearing, okay, from the north clockwise, okay, so you can see that it is what? North. So 53 degrees, 38 minutes east. This one is the what we call as the conventional bearing. Okay, so this is conventional bearing. Conventional bearing. If you check the PowerPoint in module 1, The PowerPoint in Module 1 has the slides about the conventional bearing and the simple bearing, or the what we call as the true bearing. Okay? And then if we're gonna have the true bearing or the simple bearing, so the true bearing is it is always from the north clockwise. Okay? So we can just see that since we're gonna follow the three digit, so we do have the 0, 5, 3. So we have here 0, 5, 3. Then the unit is degree. So we can just put T. Okay, it means true bearing. Okay, so this is how we are going to answer the problem. So what is the bearing of San Francisco from Honolulu? It is north 53 degrees, 38 minutes east, or um 53 degrees. That's it. Okay, let us go back to the PowerPoint. On the next problem, so it is stated here that a ship leaves San Francisco, so the same coordinates, and then sails along a great circle track, crosses the equator at point M with a longitude of 150 degrees west. So the question is, what is the distance of M from San Francisco? Or what is the distance of M and San Francisco? So we're gonna do the same. So let us draw the sphere so that we can analyze it. We have here north, south, west, and then east. Since we do have the coordinates of San Francisco, so we can see that it is west for the longitude. Then the other given is point M longitude, west also. So we're gonna have the prime meridian, okay, on the right side. So we do have enough space for the longitude on the left side. Okay, it is on the west. Next, so this is the prime meridian. Then we do have the equator. So this is the equator. Okay, then let us have again San Francisco. So San Francisco, 37 degrees, 48 minutes north. So it is above the equator. So say that this is the 37 degrees, 48 minutes north. So have the circle again. Okay. Then longitude of 122. So it is on the west. So for example, if the 122 is here, so this is the 122 degrees and 26 minutes west. So from the north, we're gonna draw a meridian that passes through it towards the south. So the point of intersection, this is the San Francisco. Next. So the ship is in San Francisco, then it sails. Crosses the equator. So if this is the equator, so it is said that the ship crosses the portion of the equator at a longitude of 150 degrees west. So 150 degrees is what? It is actually here. Then just draw meridian again from the north towards the south, passing through the said 150 degrees. Okay, and this is actually the point M. So where is the question? So distance. So we do have what? We're just gonna draw the arc here. So the arc that connects San Francisco and the point M. So considering the north, So we can have the terrestrial triangle here. Then we can already solve it using the law of cosine, same as what we did a while ago. So if we're gonna draw it, so again, if this is the north, this is M, then this is S, the San Francisco. So we have an arc here. Okay. So let us assign the letters for the sides. So opposite north is the small n. Opposite DS is the small s. Then opposite the big M is the small m. And then again, for us to easily apply the law of cosine, so we can use the letters A, B, and C. But then if you yourselves you don't need the A, B, and C, then you can directly use the law of cosines, and then it is clear with you when it comes to the letters N, M, S. So it is fine. Okay. So if we have the M, okay, let us assign M with the big A. Okay. So it means that this small m is the small a. And then for San Francisco, we can assign the big B here. So the small s will become small b. And then for the north, so we can have here the big C. So the small n is the small c. So we're going to do the same in order to solve as what we did with example number 1. So here, what we need is the small c. So it is what we need. And based on the illustration that we have, so we can actually solve for the small a. That is how, by considering the coordinates. So we're going to use the colatitude. So the colatitude. So if the latitude of San Francisco is 37 degrees, 48 minutes north, okay, so it means that the small a, this is actually equal to what? So from the north, so that is 90 degrees minus the latitude, 37 degrees, 48 minutes. Then you just use your calcu. So DMS. So again, same as what we had a while ago. So the value of A, or the measure of A, is 52 degrees, 12 minutes. And then for B, so B is so that is actually the small s. So we have here 90 degrees minus. So what is the latitude of M? Since M is on the equator, so it means that its latitude is 0 because it is on the equator. Okay? So this is 90. So 90 minus 90 degrees minus 0 degree. So our B is 90 degrees. Okay, next. For the big C. So the big C, same as a while ago. So we can use for the big C the longitudes that we have from the problem. So this is the difference in longitude. We're gonna get the difference between the two. So since both longitudes are on the west, so we do have difference in longitude. So we have to subtract the smaller from the bigger. So we have 150 degrees minus 122 degrees and then 26 minutes. Then just use your calcu. So in degree, minute, and second format, So we have 27 degrees, 34 minutes. And this measure is actually what the big C. Okay. So with the measurements that we have, so you try to take a look. So we have small a, small b, big C. So we can use here the law of cosines again. The law of cosines for what? So since we do have more um, sides, the A, B, and small c. So we can use here the law of cosines for sides. Then we can solve for the small c, which is the distance of F, rather the distance of M from San Francisco. So let us switch to the black screen. So we have again small a, 52 degrees and then 12 minutes. Small b that measures 90 degrees. We do have the big C, 27 degrees and 34 minutes. And then what we need is the small c. So what we going to use is the law of cosines for sides because we do have more number of sides and we only have one angle. So we're gonna use the third because we do have here big C and small c. So we're gonna use the cosine of small c equals cosine of small a, cosine of small b, plus sine of small a, sine of small b, cosine of the big C. Again, what we need is the small c. So we have c equals. So we can move cosine to the other side. It will become our cosine. Then just copy the right side. Then next that we're going to do, we can already substitute. A is 52 degrees, 12 minutes. Cosine, 90 degrees. 90 is measure of B, so 90 degrees. Then we have plus sine of A times sine of B times cosine of big C. Then you just use your calculator here. So our cosine of 52 degrees, 12 minutes times cosine of 90 plus sine of 52 degrees, 12 minutes times sine of 90 times cosine 27 degrees, 34 minutes. So we do have the answer in degree, minute, and second format. 45 degrees, 32 minutes, 12.47 seconds. Okay, this is on the calculator. So remember what we need is distance. So since we need distance, so what we are going to do, so since we do have here the angular measure, so from degree, we need to convert this to minute and then convert it into nautical mile so that we can have the distance. So we have 45 degrees, 32 minutes. I'll just correct this. and 12.47 seconds. So this is also equivalent to 45. So to convert it into degree alone, you just use the decimal form in your calcu. So that is 45.5367. So 5 decimal places, 9. No need to round off. 53679. Then degree. Okay, is the unit. Next. This one, we're going to convert it to minute. Next thing that we need to do. So in converting this to minute, we're going to multiply it by, so since degree is on the numerator, we should multiply it with a fraction in which the degree is on the denominator. So 1 degree is equivalent to 60 minutes. Okay, so in your calculus, simply what you can do, you just multiply it by 60. So the answer in the calculus is 2,732.2079. Then have the unit minute. And then remember, so since 1 minute is equal to 1 nautical mile, so it means that what? So it means that we do have 2,732 points. So this is 207, so 0.21. Then nautical miles. So this is the answer. So in order to answer the question, so the distance of point M from San Francisco, in which point M is on the equator, is 2,732.21 nautical miles. Okay? So let us go back to the PowerPoint. So for the last example, a ship sails from A that has the coordinates 20 degrees north, 150 degrees west. After 6 days, it crosses the equator at 170 degrees west. What is the speed of the ship in nautical miles per hour? So here, we're gonna start again with a spear. So you try to illustrate first so that you can analyze the problem. So north, south, west, then east. And then as you can see, so we do have longitude on the west. So it means our primary region is on the right side of our drawing. So we can have enough space for the longitudes, okay, on the west. So this is the primary region. And then this is the equator. Okay. Then let us locate A on our spear. So since the latitude of point A is 20 degrees north, so 20 degrees, so say that the 20 is here. So just have the arc, the circle here. And then longitude 150. So if 150 degrees west is here, so from the north, you draw a meridian. Okay, toward south. We're going to the south. Next. The point of intersection is the point A. Okay, or that is the first the first place or location where the ship is. Next, after 6 days, so the ship crosses the equator at 170 degrees. So 170 degrees west, so it is, well, here. Then again, you just draw the meridian. So this point on the equator at 170 degrees west is the other point. So for example, if you would like to use point B, okay, or letter B, so you can do it. Then, so since the question is speed, remember that speed, if you can remember the formula for speed, speed is distance over time. So for the time, we already have here the days. Okay, 6 days. So since the speed, what we need here is the hour for the denominator. So we're just gonna convert the 6 days into hours later. Okay, so we already have here the time. What we don't have is the distance. So we need to solve for the distance first. So the distance that we need is from A to B. Then just create the terrestrial triangle. So this is the terrestrial triangle that we are going to use. So if we're gonna draw the triangle here, so we have here the north, then this is the point B, then this is the point A. So this is the terrestrial triangle. And if this is north, so this part, this side is the small n, this is the small a, this is the small b. Okay. So since we already have the A and B, we're just gonna use the big C for the big N or the North Pole so that we can have here the small c. Okay. Next, so we need to determine the measures of small a, small b that is coming from the given. So for the small a first, knowing that we do have B on the equator, which has a longitude of 170 degrees west, and since the point is on the equator, so it means that its latitude is what? 0 degree. Okay, so if this is 0 degree because it is on the equator, so the distance from the North Pole going to point B, okay, it is what? It is 90 degrees minus the latitude of 0. So this is 90 degrees. That is our A, 90 degrees. That is the angular measure of this side from north going to point B. Next. For north to point A, so since in the given, so we do have the latitude of point A that is 20 degrees north. So we're gonna use the colatitude. So same with this one. This is also colatitude. So we have 90 degrees minus 20 degrees. So this is 70 degrees. Okay, so from north going to A, the distance is 70 degrees. So angular measure. So we have B equals 70 degrees. Okay, next. We don't have a small c yet because it is what we need to solve, okay, for the distance so that we can get the speed later. So same with the other examples a while ago. So what we can what we can get from the given is the difference in longitude coming from the coordinates of A as well as of the point B. So the difference in longitude or the d long, okay, d long, you can see in other sources that it is d apostrophe long. For others, it is written as this one. For other sources, it is, well, it is like this. So we're gonna subtract the smaller longitude from the bigger one. So since we do have here 150 and then 170, considering that both are on the west, so we're just gonna subtract. So we have 170 degrees minus 150 degrees. So we do have the difference in longitude, which is 20 degrees. And this 20 degrees is actually the measure of our big C. Okay. So if we try to look at our given again, so we have small a, small b, big C. So what we can use here is the law of cosines. For what? Is it for sides or for angles? Since we do have small a, small b, and small c here, in which small c is the unknown. So what we're going to use is the law of cosines for sides. Okay. Then, so we're going to switch to the black screen. So rewriting the given, we have small a, 90 degrees, small b, 70 degrees, big C, 20 degrees, and then what we need here is the small c. Small c is the distance. Because remember, in our problem, what we need is the speed. And speed is distance over time. So given the time, we do have here what? We do have here 6 days. Okay. So using the law of cosines for sides, so if you can notice, we do have here big C and small c. We're going to use the third formula. So that is the cosine of small c equals cosine of small a, cosine of small b plus sine of small a, sine of the big C. So we need the small c. So we have c equals. So just move the cosine to the other side. So it will become arc cosine. Copy the right side. Then we can already substitute. Then you circle Q. So we have our cosine of 90 times cosine of 70 plus sine of 90 times sine of 70 times cosine of 20 degrees. So we do have in DMS, because this is still the measure of side C, angular measurement, we have 27 degrees, 59 minutes, and 27.21 seconds. But then this is not yet the answer because we need to convert it into distance. Okay, so in order to convert it into distance, so I'll just erase the upper portion here. So for distance, so what we need is to have the degree, okay, converted to minutes and then converted to nautical miles. So because we do have the angular measure of side C, which is 27 degrees, 59 minutes, and then 27.21 seconds. So this one So you just have the decimal format in your calcu. So it is 27.9999089. Then have the degree unit. The next, what you need to do, you have to convert it into minutes. So be sure that you're using the 5 decimal places so that somehow we can have the answer that is closest to the real one. So since we need to convert it into minutes, so we know that in 1 degree, there are 60 minutes. So in your calcu, so you just multiply it by 60, the answer that you have a while ago. So we have 1,679.45344 minutes. Okay. Then again, since we know that 1 minute is equal to 1 nautical mile, okay? So it means that we have what? So we have 1,679.45344 nautical miles. If ever that you will be asked of the distance, so you can just have the 2 decimal places. So the distance between point A and then the point on the equator is 1,679.45 nautical miles. If ever that is the question, so you can have your final answer in 2 decimal places. If the said result here is not considered to be the final answer or one of the unknowns in the problem, and you're gonna make use of it as part of the solution in solving the unknown. Just like in our problem, what we need is the speed. So we're gonna make use the 5 decimal places. Okay, so that our answer in the end will be closer, closer to the real answer. Okay, so we do have speed. So since we already have here the distance, so this is the distance. So again, so since we have speed, okay, S equals to D over T, or distance over time. So we can already have here, so I'll just erase this portion so we can have enough space. So the distance is 1,679.45344 nautical miles. Okay. Remember in the problem, we are asked of the speed in nautical miles per hour. Per hour. So this is NM. This is hour. So it means that the 6 days, we need to convert it into hour. So for the time, 6 days. So of course, you know that in 1 day, there are 24 hours. So that is 6 times 24. So we have 144 hours. And we're gonna use this in the speed. Okay, in solving for the speed. So we have 144 hours. So just use your calcu. So S equals, so we have 1,679.45344 divided by 144. So the answer is 11.66287 nautical miles per hour. So since this is the unknown in the problem, so we can already have the two decimal places. So 11.66 nautical miles per hour. So this is the answer. So the speed of the ship from A to the point on the equator after 6 days is or let's just say that in 6 days is 11.66 nautical miles per hour. Okay? And so that's it for the application of spherical trigonometry considering the terrestrial triangle.